Welcome to the pre-calculus video for skill number 30. I can find the slopes and intercepts of linear models and interpret meaning within context, including points of intersection and finding parallel and perpendicular lines. So this skill, there's actually a lot of things that we're doing. This is kind of a review of stuff back from earlier in the year. The important thing is we are going to now take our slopes and our intercepts and apply context to them. So we're going to do that. The video notes are going to focus mostly on how to find those, and I'll try to hit a couple examples of models as well. Also, we're going to discuss what is the meaning of the intersection of two linear models, and we're going to review how to create parallel and perpendicular lines. So the trivia question for the day is, here we have a pair of boots, and on the sole of the shoe, or the tread of the shoe, we have these little knobs that stick out, and the trivia question is, what are those knobs called? Alright, so as we learned in the previous skill, the equation for slope is the change in y values over the change in x values. Or if you want to think of that rise over run, you can do that as well. We also learned in the previous video that the point slope form is y minus y1 equals m times x minus x1. So if you're given your slope and you're given a point, then you can fill that out. And then the slope-intercept form is y equals mx plus b. And I would say that the slope-intercept form is pretty nice when you're talking about problems in context. So we're going to see some of that today. And the relationship between parallel lines. So parallel lines have, this is a symbol for parallel. So parallel lines have the same slope. And then the relationship for perpendicular lines, that's the symbol for perpendicular. Perpendicular lines have negative reciprocals, a negative reciprocal slope. So a negative reciprocal might be like you have 7 and negative 1/7. So those are the key facts to know for today's lesson. Let's take a look at some of these problems. Alright, the first problem type we might see is just generating an equation from a graph. And what we have here is our red line has a y-intercept of 3, 1, 2, 3, and it has a slope of, looks like, down 1, run 3. So our red line has the equation y equals negative 1/3 x plus 3, because we have a slope of down 1, run 3, and we have a y-intercept of 3. Our black line has a y-intercept of negative 1, and then the slope looks like it's down 3, run 1, so it's a negative 3x. And then finally our blue line is a horizontal line, and all horizontal lines have the equation y equals some number, and that number is where it's at. So we're at negative 2, so y equals negative 2. All horizontal lines, no x's. The second example here, we'll start with a red line. The red line has a y-intercept of 1, so we can write plus 1, and it looks like the slope is, a little bit harder to see this one, but you can see 1, 2, 3, 4, 5, run 1, so it's got a slope of 5, so y equals 5x plus 1. Our black line has a y-intercept of negative 1, so y equals something minus 1, and it looks like our slope is down 1, run 2, so down 1, run 2. And then finally we have the vertical line. And a vertical line always is of the form x equals some number, and that number is 1, 2, 3. So x equals 3. So what we've learned here is horizontal lines are y equals a number, and vertical lines are x equals a number. Alright, the next task that we might be tasked with is how to find x-intercepts. And an x-intercept you can think of as where the graph is crossing the axes, the horizontal axes. So sometimes people call these the horizontal intercepts. And this occurs when y equals 0. You see the y coordinate is 0 there. So what we do is we set equation equal to 0 and solve for x. Some tips here. There is, for linear equations, there is only one solution, or at most one solution. In general, you could say that there is any number of solutions, 0, 1, 2, 3 solutions possible. However, for linear equations, we typically only have one solution. Unless it's a horizontal line, then it's possible to have no solutions. But we'll never have more than one with a linear equation. Later on we'll learn that the degree of the function tells us the number of roots possible. Right. So for the y-intercept, we're looking at where is the line crossing the vertical axis. So sometimes we call the y-intercept the vertical intercept. And for this we let x equal 0 and solve for y. So let's try that on these two problems below. If we want to find the x-intercept, that says set the equation equal to 0. So we say 0 equals 5x plus 15, which means negative 15 is equal to 5x, which means negative 3 is equal to x. So we have an x-intercept at negative 3, 0. X-intercept, and then the y-coordinate. If we want to find the y-intercept of this equation, what we do is we let x be 0, and we solve for y. And if we do that, we get 15 equals y, because 5 times 0 is 0, which means we have a y-intercept at 0, 15. You'll notice that I listed my x-intercepts and y-intercepts as ordered pairs, and that is the format I would like to stick to for the duration of the year. Doing this for the second problem, the x-intercept, we first set the equation equal to 0. 0 equals negative 2x plus 24, and then we get 2x is equal to 24, x is equal to 12. Which means we have an x-intercept at 12, 0, and then we do the y-intercept. Y is equal to negative 2 times 0 plus 24, and we get y is 24, which kind of jives with our statement that this is the y-intercept for lines. So our y-intercept occurs at 0, 24. Alright, moving further down the page, we are being asked to find the equation of each line and use this to determine if the lines are perpendicular, parallel, or neither. So line 1 passes through those two coordinates. So if we find our slope of line 1, we're going to get negative 2 minus negative 5. So y2 minus y1 over x2 minus x1. and that gives us a value of 3/2. So you could say, using the point slope form, the equation of our first line is y plus 5 equals the slope times x minus 1. For line 2, we're going to find the slope of line 2, and we do y2 minus y1 over x2 minus x1, and this gives us 2 over negative 3. And if we create the line equation, y minus 7 equals negative 2/3 x minus 2. When we compare our slopes, we see that they are negative reciprocals of each other, and negative reciprocals indicate that the lines are perpendicular.
Like beef. I smell 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 like beef.
Alright, so sometimes we're asked to find where two lines intersect. And if we want to do that, there's actually several different methods. And the method I'm going to show you is called the equal values method. And I wouldn't say that it's the best method, but it definitely works. Step 1 is, what we want to do is set both equations equal to 0. Sorry, both equations equal to 0 or equal to y. In other words, you'll have one equation that's maybe y equals 3x plus 8, and the other equation is y equals negative 2x minus 5. In step 2, because both equations equal y, we can set them equal to each other. So we set equations equal to one another. In our example here, what we'd say is 3x plus 8 is equal to negative 2x minus 5. In step 3, we use algebra to solve for x. So if we did that to this problem, we would add 2x to both sides, and we'd get 5x on the left, subtract 8 from both sides, and we get negative 13 on the right, and finally get x is equal to negative 13/5. Step 4 is we're going to plug x into one of the original equations. Doesn't matter which one, we could plug it into either. And we'll use that to solve for y. And if we did that with this problem, what we'd have is y is equal to 3 times 13/5 plus 8. Doing the math on that, we should arrive at y is equal to 1/5. And then finally, we would write solution as an ordered pair. So our ordered pair for this problem is the x-coordinate of negative 13 over 5 and the y-coordinate of 1 over 5. And what that means is basically if we were to graph our two lines, 3x plus 8 probably looks something like that. Actually, it's probably steeper. And then the second one, y is negative 2x minus 5. So maybe something like that. I don't know. And the coordinate where they intersect is this coordinate. Alright, so let's do that with an example. Example 4, find where two lines intersect. Oh, they don't give us the equations. They give us 2 points. So we're going to have to generate the equations. So let's do that for the first problem. Okay, so I went ahead and solved these. This should be -5. And what we have is we first found the slope for each line, then we plug this slope into point slope form for each line. So to go through our process, we need to solve each line for y. So if we solve the first one, we're going to get y1 is equal to 2x minus 4 plus 10, that's 2x plus 6. And our second line is y equals -5x plus 13. So we have our two equations, and to solve them, or to find where they intersect, we set them equal to each other. 2x plus 6 is equal to -5x plus 13. We add 5x to both sides and we get 7x. We subtract 6 from both sides and we get 7, and this gives us a value of x equals 1. But we also need the y-coordinate, so we can stick x equals 1 into either one of the equations, and we better get the same answer. So if I plug 1 into the first equation, I'm going to get 2 plus 6 is 8. If I plug 1 into the second equation, I get -5 plus 13 is also 8. So once I plug both of them in, or plug it into both, I see that y equals 8 is the correct answer for both equations. So my solution as an ordered pair is 1, 8. Alright, thanks for watching the video. In class we'll try to use more examples with linear models so that we can really contextualize our problems, so that we'll have meaning behind all of these things. And the answer to the trivia question was, if you were to take a look at the bottom of a pair of boots, you have these knobs on the bottom, and they are called lugs. So the little knobs at the bottom are called lugs. Thanks for watching the video. Have a good day.